Hello, this is Jim with the part 3 of the network analysis. Before doing this, we suggest you do review part 1 and part 2 because we have solved this circuit up here using loop equations. Okay? Alright, so we start out with the same circuit. Even though we do know the answer, this will actually reinforce this new concept using Nortons Theorem. Okay? So, how to begin with this, what is different, is we convert these voltage sources to current sources. As an example, the 12 ohm and the 84 volt source, that can be converted to 7 amps because that's going to be the maximum current flowing in this branch. The maximum current is limited by the 12 ohm resistor. So that becomes 7 amps. That we show right here. We do the same thing on the other side of the circuit. The maximum current would be 7 amps. That places these three resistors in parallel. The 12, the 6, and the 3. Okay? Current sources are used in other parts of electronics and analyzing circuits, transistors, and integrated circuits. So this may be a new concept, the current sources, for some folks. Okay? Now, notice the arrows are down. That shows the direction of the current. The magnitude of each one of these is 7 amps. This is figure number 2. Okay? In figure number 3 here, we have combined the two current sources to 14 amps. We call that I Norton, or abbreviated IN. Okay? Here we got the 12, the 6, and the 3. So we've simply simplified the circuit in figure number 3. Now we further simplify by looking at this thing. We got to decide which resistor we want to find the current for. Well, the easiest one is the 6 ohm. We already know what it is. Okay? If I can find the 6 ohm, I can find the rest of these by the procedure shown in part number 2. So we do that here. We combine the 3 ohm and the 12 ohm, those in parallel, those two in parallel, nets us a value of 2.4 ohms, as shown here. This is referred to R Norton. Okay? Alright? The I Norton is 14 amps. So this is the equivalent broken down. Now to find the actual value, we use the current law, Kirchhoff's current law. Okay? Alright? So that current, I 6 ohm, is equal to I Norton times R Norton over R Norton plus R6. That's 14.2 times point. Alright? That's 14 times 2.4 over 8.4. And there we have it. Comes out to 4 amps. That's all there is to it. So the current flowing through this resistor is 4 amps. It's going up from bottom to top. Now the advantage of this method is that we can change this value to any value and determine the circuit parameters. In other words, we could change this to 12 ohms. And then change this to 12 ohms here, and we would have the current through the new 12 ohm resistor. So this Norton equivalent here stays pretty constant. The 14 amps is I Norton. The 2.4 ohms is called R Norton. And here we use the current divider rule to solve the circuit. Very simple and straightforward. This is indeed simpler than the part 2 method using, or part 1 and part 2 method of using loop equations. I hope you enjoyed the presentation. Any additional information you might want, you can get by emailing me, w9jug@outlook.com. Thanks for watching.